like, subscribe, press the bell icon for more updates. For more videos, download our app from Play Store. Faculty Diploma Program. Welcome to second session of Machine Learning and Data Science using Python.
We'll start. Good morning, everyone. This is Lalit from PHN Technology. So we are here to attend second session on data science and machine learning with Python. I welcome you all professors and faculties for the second session. I would love to give a basic introduction of PHN because we have some new faculties to join this session. So basically PHN is a edtech startup. We started as a software company, but we are expanding into educational domain. In this, we are conducting faculty development programs like our school college student program. In this college student program, we are conducting take you off workshops. In this, we are arranging workshops on different 6 topics, and we have some good expertise connection in industries, and they are going to conduct these sessions. Please everyone mute yourself. Okay, so basically we have shared all the information with you in last lecture, and we also share the registration form with you. But if many of the colleges are joined and register their students on our this workshop program, but we will share once again the link, so you can just share with your students. If anyone missed this opportunity, so that's why we are sharing the registration link. I would love to introduce our new trainer. So basically we have trainer Sushant Moon. It's my pleasure to introduce our esteemed faculty. Sushant completed his BTech in computer science and engineering from IIT Guwahati in 2015. Since then, he has been exploring various topics in machine learning, software development using Python, C, C++, R, Scala, JavaScript, SQL. He has worked with many clients across the globe to build the big data and machine learning solution and help the private circles improve their search backend. Currently pursuing his MTech in computer science at Indian Statistical Institute, Kolkata. Please join me to welcoming Sushant Moon, our faculty development program trainer. Sushant, you can continue.
Yeah, thank you. Thank you, Lalit. So hi guys, I am Sushant Moon. Let me start with sharing my screen. Okay. Just not before that. So as Lalit mentioned, I am a BTech graduate from IIT Guwahati, and I have done my masters from ISI Kolkata, right? And I have been in the industry for past 7 years, working with different verticals, and have been working mostly with data science. All complete 7 years, I have been working in data science itself, right? So yeah, in today's session, what we will be covering is in the last session, our guest our speaker in the last session had covered definitions around what is machine learning, supervised, different types, supervised, unsupervised. Then he also covered different examples, right, pertaining to different domains. Then he explained ML workflow, problem statement, feature engineering, modeling, experiments, and so on, right? He also helped you install Jupyter Lab via Anaconda, and also give some basic listings, right? So moving on with that, right? Today, as mentioned in our last class, we will be we'll be taking a deeper look into fundamentals of Python, right? So what Python is as a language, right? What are the nuances, operators, functions, lists, dictionaries, what are generally used, right? What I have been using in the industry, right? So I'll be focusing mostly on that. Then post that, like I will be talking about pandas, NumPy, Matplotlib, and how that helps with the actual data analysis, right? So that would be second part of this lecture, right? Maybe you can type your questions in the chat bot, in the chat section, right? I'll be having a continuous I'll be taking a continuous look on it as well. So yeah, so we can keep it interactive, like via the chat, right? I will try answering everything, but in case let's say like there are a few questions which are left out, we will handle it towards the end of this session, right? Because like we have a lot of ground to cover, since we are starting right from the scratch, right from what Python is, right? So yeah, um, thanks. So yeah, let's start with this. As mentioned, like we will be starting with basics, uh, and looking into how Python is actually used for data analysis, visualization, and exploratory analysis, right? Uh, so yeah, back to the topic. I am Sushant. I am data scientist at Amazon Web Services. Yeah, and special thank you to Stanford University for these excellent slides. Yeah, so for any programming language, there are few basics, right? So there is something called code is a word that will be code, or source code is something that we will be using very frequently, right? So that's nothing but a sequence of instructions in a program, right, in a text file, which our computers can understand, right? And then syntax is nothing but a legal set of, or legal set of structures and commands which basically our system understands, like our uh, program can understand, our machine computer can understand, right? Then output is nothing but the output which is basically given back after interpreting the code that the computer has run, right? And console is nothing but the um, terminal window, a window where you are communicating with the engine, right? Engine can be nothing but like it can be for C compiler, the terminal, the CMD, the console in the Windows, right? So it can be anything. Moving on. So what happens in Java, C, C++, and so on? Like these languages are compiled languages, right? So these languages, the source code needs to be compiled into machine interpretable format, right? And then it is basically executed, right? For example, in Java, the .java file needs to be compiled to a bytecode, right? And then it is to be executed, and that's how it usually is for most of the languages. But then Python is a interpreted language, right? So it directly uh, so what happens is when it executes instructions step by step in a serial manner, so you don't have to compile your Python code or .py file. You can directly run, so systems directly run the py file, and hence it is usually on the slower end as compared to the languages like Java, C, C++, and so on. Yeah. So reason being, because this is a interpreted language. Yeah. But then again, why it has been so popular, right? So because of this interpreted behavior, like how it interacts with the, how easy it is to use, hence it has been widely adopted across industry, like machine learning, AI development, and so on. Reason being, given it is easy, it is easy to understand that language and how the way it functions. The task like implementing complex algorithms gets easier. The algorithms per se here being machine learning algorithms, right? So those tasks become bit easier in this particular language, right? So what's Python interpreter, right? We will be taking a look at it later on in our demo. But as you can see in the screen, like what you give is you just give it an instruction like 3 plus 7, that it will directly give out, like it could directly, you don't have to compile what's 3 plus 7 and to execute the file. You just write 3 plus 7 and the output is directly given in the console as 10, right? So you can give any number of commands and it would basically interpreted directly from that single line and so on, right? It would just move on. So different so as in maths we have symbols, right, for addition, subtraction, multiplication, division. Similarly, we also in Python we have a same symbols, that is for plus for addition, minus subtraction, asterisk for multiplication, slash forward slash for division, right? That's particularly integer division, right? That is to be noted. And then modulus symbol, which is for remainder, like obtaining a remainder from a division, right? So given how that is used, just like how it is in maths, right? So each symbol has a precedence. So we have a Bodmer's rule, right? So similarly, Bodmer's rule also applies here. And to then to give a then you can use parenthesis to basically give a precedence to a particular equation to handle this, to handle how the equation needs to be solved, right? So same Bodmer's rules applies along with brackets and so on. So what I meant by integer division is like, let's say if you are dividing 14 by 4, right? So what happens is you'd get the quotient 3 and the remainder would be 2. But let's say in I think, sorry, I was unmuted. I was muted. Am I audible, right, everybody? Over the slides?
Yes, sir.
Cool.
Yes, sir.
Yeah, cool. Okay, then. So what I was saying is, yeah, what integer division looks like in Python is when you divide 14 by 4, the quotient is 3 and remainder is 2, right? Yeah. But then the Python would only be giving you output as 3. The remainder would not be given. Similarly, more examples as shown, like 35 by 5, 7, there is no remainder, so that's directly there. But in case of 84 by 10, the 8 is what the output would be given. There would be no there would be no remainder would be given. In case you need the remainder, then you would be using the percentage operator, right? Basically that would be executing the modulus, and that's how you basically get the remainder as well, right? So that's the integer division that is there in Python. Then Python also has the capability to store real numbers, right? So you can store long floats, right? Real numbers, you can specify it as like 42.0 or 2.4143 17. That is nothing but 2.143 into 10 raised to 17, right? That's how long real numbers can also be stored with the hexadecimal, right? So it's not like, let's say, unless the number is float, right? Unless a number is real number, right, you would be getting the results in integer division. But let's say in case of, let's say, if you are dividing floats, then in that case you would be getting a decimal value, like in decimals as well. Like let's say if you do division of 1 as an integer divided by 2.0, right, the output would be 0.5, right? So this case is of division with, like, the numbers here which are interacting are floats, and hence the 0.5 was given as an output. But in case of, if you would have just done integer division, which is like using 1 as standalone and divided by 2, you'd be getting 0 as quotient, right? So that's how you, depending on the numbers that you are using and the data type, will be coming at what data types are. Depending on the data type that is associated with the numbers, the output changes, right? So that's the basic behavior. Coming to the maths command which are there available by default, right? So you can use max, min, round, square root, log of 10, floor, ceiling, and so on. So there are n number, like there are a lot of different functions by default, which comes mathematical functions, which comes with comes with Python, right? And it's all there by default, right? You can directly use them. And so that particular library is math, right? Then coming to, yes, so I talked about floating numbers, right? Real numbers. So let's say if you have a number, for example 1.23 232, right? So in this case that would be directly taken in as a float, right? But okay, slides were moving, just a second. Yeah. Huh. But let's say you want to convert this 1.23 to into integer. So what you would be doing is you would be writing any number that you want to convert into integer. You just want the integer part, then you just do int, basically integer, in brackets you just write x, right? So that's how you get the integer part, right? So here in example, let's say int 2.0, then you would be getting a integer 2. Let's say if you write, then float is the corresponding real number, right? With decimals. So let's say if you write float in brackets 2 as shown in the slides, right? Let me use the pointer. Yeah, as shown in the slides. So you would be getting 2.0, which becomes a real number, right? So that's how you change the data types, particularly for number. So int, float are nothing but the data types, right? So as you can foresee, there would be particular data type for strings as well, right? So we often in our day-to-day life, like we often have strings as well, like we type alphanumerical characters to make sense as well, right? So strings is also one another data type. So yeah, we'll be coming into it as we go along, right? So we in our last slide we encountered, just we were basically just using numbers, right? um yeah, we were just using numbers directly, right? Like 1.232, but we didn't had an option to store that number in a variable, right? So what's a variable? Variable is nothing but a piece of memory where you can store the value, a particular value, right? So it can be the piece of memory can be annotated with anything, right? It can be in anything, in sense it should be starting with alphanumerical alphabets, and it can end with numbers as well, right? So it's basically a name value pair, and the syntax is as shown, like name equals to value, and that's how you define mm, that's how you define a variable. So let's say I want to assign uh, a variable x to 5. So so you just have to write x equals to 5, and that's how you get. So anytime you use x as a variable, you'd be getting the value as 5. So x plus 4 would evaluate to 9, because x has already been assigned a value of 4, so value of 5, right? So these are some other examples, right? Like you can do x equals to 7, then x plus 7 would be 14. That is the output which is given by the Python interpreter, right? Then again, like you can also rewrite x variable to a new value, because in the end, it's x is just pointing to a location in the memory, right? So x can be also be used to point to something called hello as well. So that's how you, like x equals to, and you just do in quotes write hello, and you get hello stored in the memory location where x is pointing, right? So that's one example. And then there is something called print. Print is to print any message, debug statements, and so on, right? So let's say in your console, right, you write print hello world. So hello world is something that would be printed back on the console, that is on the standard output, right? So standard output in this case would be the console itself. Yeah. mm, okay. So these are different examples, right? Print hello there, and that's how, like, if you, so this was particularly syntax for Python 2.0, like in 2 version. Nowadays, like 3 is the version which is popular, right? So we'll be working with, in our demo, we'll be working with Python 3. At times you would be writing programs which would be needing inputs, right? So input is the function which enables you to take in values from the console. Basically, you ask, let's say you want to ask from the user of the code, what is his age? So you just do age equals to, basically age is the variable where you are assigning whatever value that the user is inputting to the age variable, right? So you, in input, you write how old are you, and in the console, when the code runs, it would basically wait for the user to input his age, and only then it would move. It would execute the next step. It would let's say if I give the output as 53, then in the variable age, the 53 as an integer is stored, and it then proceeds. So in this example, a we are doing age equals to input how old are you. So one, and then the next step statement is print your age is whatever the age input is, that is printed back, right? And in the third line, what they are doing is you have 65 minus the age, years until retirement, right? So this basically changes it. So that's how, so in this case they are just doing a simple subtraction, 65 minus whatever the value that you gave, to calculate the age to retirement for this particular case, right? So in this example, so that's how inputs are taken. Then raw input is another format for input, right? Where you can take, like, similar to input, raw input is another function which can be used to take in the inputs as well. Then okay, so now any questions till this point? Okay, okay, then moving ahead, we'll be looking into loops, right? At times we'd be wanting to do something, right? Write codes which are doing a particular action in loops, right? Recurringly in a particular format, right? So, and then we also have conditional steps, right? Let's say if the age of a person is greater than 30, then we classify that person as a young adult, right? Let's say if his age was less than 10, then we classify the person as a child, right? So depending on how, so to write such statements, conditional statements are always required. And then for loops, let's say if you want to iterate over numbers, right? Like 1 2 3 4 5 6 so on till, let's say, 99. So you just don't write all the numbers in one go, right? So loops are something that can be used for this particular case, right? So that is what we will be looking at next. So first is the for loop, right? What happens is, let's say you want to iterate over a,
over the 25
let's say you want to iterate over a group of values one by one. So what happens is, the way that you would be doing is, just let me mute everybody. mm, yeah, sorry, I just muted. mm, yeah, so to iterate over a group of values, what you would be doing is you would be using for loop. So the syntax for it looks like, for any variable name that you would want, right, in group of values, right, and the statement that you would want to execute, right? So in this case, like, let's look at the example itself, right? So range, we will come to range, what range is, but think of it as a generator of numbers, right? First becomes the start value, and the second argument that we give it to it becomes the ending point to it, right? So what happens is when you write something like for x in range 1 to 6, so this statement would execute from 1, start from 1, go till 5, and then terminate, right? So in this for loop, what they're doing is one by one they are going taking, like, one by one the value from this particular range is coming into x, right? And that value is just being printed as x square, right? So the expected output here is basically for the value of x equals to 1, the square is 1, then 2 squared is 4, and so on till 5 squared is 25, right? And at 6, basically the for loop terminates. So this is how you write the for loop. So this is very simple. As you can see, this Python as a language, it becomes very easy to understand what the statements are written, and hence this was the major reason for it to get popularized among all the folks which are there, right, among the general populace. Next, just a second. Yeah, so next, so as I mentioned, range, what range is, right? So range is basically a function where first argument is the starting point and the second argument is the stopping point. So basically the start is inclusive and the stop value, whatever that you give, is exclusive. And also there is a third hidden argument which is called step. Basically it tells you how many steps you would have to take to stop, when you are moving, right? So that basically specify the steps with which you move. So in this case, let's say if you start with 5 and you'd want to go to 0, right? The default value of step is +1, but let's in this case we are wanting to go from 5 to 0. So in this case we would need to give the step as value -1, so that the value of x decreases till 0. And hence if you look at the output, right, it counts from 5 to 1, and then only then it exits. Only then it basically exits the for loop, right? So that's how range as a function behaves. Yeah. So let's say you would want to find out cumulative loops, like you'd want to do cumulative sums, right? So let's say if you are doing counting from 1 to 10, like you just want a sum of all the numbers. So what you can sum of all the numbers, or in this case the example is basically sum of first 10 squares, right? First 10 squares from starting from 1 to 10, what is the sum of all the squares? So what you'd be doing is you can use a variable sum, right? In this case we are using sum as a variable which initially has a value of 0, but as it goes by in the range, what we are doing is we are in the variable sum, along with its original value, we are storing we are also adding it with the value of I plus I square, right? So what happens in the loop is, so the loop functions as functions as this. So first sum equals to 0 is defined, and then in for loop, for I in range, the start value is 1 and the end terminal is 11, right? So this range would be this would be counting from 1 to 10, right? Because the last value is exclusive. So after that, inside the loop, what's happening is we are adding the value of sum and I square to itself. So how this is calculated? It is calculated from right to left. So it first does I square. Python first calculates I square value. then it checks what is the value which is already stored in sum. Then sum plus I square is calculated, and this complete value is stored back again in sum. So that's how you do a cumulative sum of first 10 squares. So and at the end you just get the sum of first 10 squares. So that's how the cumulative loops are written, and that's how you can use store the same value back into itself, right? And do some complex calculations as well, right? And now coming to if statements, right? So if statements are helpful when you are wanting to write conditions, right? So let's say in this example, so okay, first coming to the syntax. So syntax is pretty straightforward. You just have to do if, state the condition on which you'd want to execute the particular statements, right? And within it you write the statements. So with this flow chart, it it should be clearer, right? So at any point in time, let's say once the Python interpreter comes to the if statement, it would check whether the condition, this condition that you have written, is it true. If it is true, then it takes this second branch, yes, and executes the statements which are within the if statement, right? And let's say if the value is no, then it basically skips all the statements which are written within the scope of if, right? So for example, let's say the GPA is 3.4, right? And in the if statement, we just say if the, let's say the condition was GPA needs to be greater than 2 for the application to be accepted. So it would just check whether the GPA is greater than 2, 2.0. So in this case, our GPA is 3.4, which is greater than 2, and hence the yes statement, like this condition is true, and hence this next step is executed, right? Let's say you are wanting to add more conditions, right? Let's say if a condition is true, do something. If do X, and let's say if the condition is false, do Y. So what to do? So that, so for that particularly, the syntax looks like this. So if condition, then statements, and then else, you write else, and then the following statements, for the statements which you want to execute when the condition fails, right? So this is how the chart looks like, the flow chart looks like. So if the condition is true, it executes as we have seen previously. But let's say if the condition is false, right, any condition which is written in the syntax is false, the statements which are written within the scope of else are basically executed, and only after that the if else condition is basically finished. So yeah, so let's say we want to write a program where we accept candidates who have GPA greater than 2, right? And let's say we reject the candidates who have GPA less than 2, right? So for that, the condition statement should be looking like, if like GPA, would we still use that as a variable to store the student's GPA, right? We use if GPA value, the value which is stored within the variable GPA, is greater than 2, we just print out welcome to Mars University, right? But let's say if the GPA is less, then else statement is executed, which says your application is denied, right? And in this case, GPA is equal to 1.4, and hence which basically makes this condition statement, right, a GPA greater than 2, a false statement, right? Hence it goes within the else part of the condition, and the statements which are written within the else condition are executed. So this is how you use else, if else. But let's say if you have multiple conditions, right? So if something happens, do XYZ. Else if let's say condition number 2 is met, then do ABCD. And finally, if none of the condition makes the cut, or none of the conditions hold true, only then else statement is basically executed. So this is the syntax that you can see on the, for writing else if conditions as well, right? So you can chain in multiple if conditions within uh, within if else as well, right? Depending on the complex depending on yeah, depending on how the what is the purpose of the application and what needs to be executed after what. So I see in the chat there is a question asked by Sumit, which says how to end the for loop. So what happens in the for loop is you just write the statements which are there in the scope of for loop. So let me just go back. I'm going to a simpler example. Yeah. So what happens is, once in any for loop that you write in Python, right? Once anything that you write, as I mentioned, Python is a uh, interpreted language, and it goes step one instruction at a time, right? So what happens is, anything like you can see there is an indentation. So anything which is written within the indentation of for loop will be executed step by step. So in this case, first the value of x is 5. So because there is nothing below it, like in the scope of for loop, right? This print statement is the only thing which is in the scope of for loop, right? So first it takes the value of 5, which is printed out, then it takes the value of 4, and so on. It takes till 1. Now, because this range, the numbers which it is iterating over is finished, the for loop ends, and hence it prints blast off. Okay, hope that helps. Moving on. So these are the examples for if statement, right? So let's say you you have a condition where x is, let's say, if less than or equal to 15, you add x plus 15 to a variable y. Let's say if x is less than or equal to 30, you add 30 to the value. If else if is, and at the end, like if none of the condition meets, then you just assign y equals to x. Then at the end, you just do you print y, whatever the value of y is, and do the math, like you apply a function called sin, like basically sin of y. So that particular value is basically printed. So how it goes is, like, let's say right now in the example, x equals to 30. So first condition doesn't hold true. Second condition basically meets the value, right? Because as x is less than equal to 30, so y becomes x plus 30, that is 60. So the value of y which is printed is basically y equals to math dot sin of y. So sin, this is the sin function which is there in trigonometry, right? So that is particularly applied to the sin. 60 is 0.999. It's basically essentially 1. So it's very close to 1, right? So that's how it goes. So that's how else if statements are executed. So coming on to coming on to the other way to write for loops, right? So while is another method to write the for loops, right? So what happens is, you just so while in while condition, the syntax looks like this: while condition. So until the condition holds true, the statements which are written within the scope of while loop are executed. So this basic essentially mandates while condition can run indefinitely, right? So it would just continue consuming resources, but you would have to write a particular condition where, such that, like, So this writing for loop is bit tricky because of this thing. So you would have to make sure to write a statement in the statements, right, in this particular part, that makes the condition equals to false when the desired result is achieved. So like what I mean by that, right? So let's look at an example for this. So what I do is I assign a number, like number as a variable equals to 1, and I run a while loop. So what I do is I basically write while number as a variable, the value which is stored is less than 200. I print the number and I basically multiply the number by 2, right? So what I'm doing is now remember, these kind of equations are evaluated from right to left. So in the after print statement, what they are doing is they're using the value of number, which is 1 at the first go. It would do 1 into 2. That multiplication is stored back in the variable number, and then the while loop is again evaluated, and then so on. Then at the second iteration, the number would be having variable 2, right? It would just basically print number 2 and then multiply the number with 2 as well and stored back to number. And this loop basically continues till number as a variable has a value which is less than 200. So as in the output, as you can see, it went till 1, 2, 4, 8, 16, 32, 64, 128, because the next value would have been 240. Yeah, so it would be 256, right? So next value would have been 256, and hence at the end the while loop basically broke, right? So that is how, this is how you basically uh, you basically make the condition which is written in the while loop as false to break out of the while loop, right? So one must be very careful when you're writing while loops. This is one another example. They are basically going to they are incrementing the value of x 1 by 1 and printing it, right? So once the value of x becomes 10, the while loop breaks. And that's another example for while loop. So as given, like there are list of, like we wrote conditions with some operator values, right? So similarly, there are different operator values which are there. Operator functions which are available for us for logical equations, right? To write conditions. So there is double equal to check whether the two values are equal, right? There is exclamation equal to, which means does not equal to, less than, greater than, less than equal to, greater than equal to. All these values are there. And also there are logical operators as well, right? So you can use and, or, not as well to check, to write complex conditional values, right? So just like in our mathematics, we have and as a logical expression, right? Or not, right? So these values are also there. So basically, and is basically like only this and would be true only if the two statements which are within which are basically written side by side are true. So in this case, 9 is not equal to 6 and 2 is less than 3. Hence, on a higher level, this complete statement becomes true, right? Similarly for or. So or is like either one of the two statement needs to be true for the or operator to be true. So in this case, 2 equal to 3, which is false, but like we have used or operator, but 1 minus 1 is less than 5, which is true. So because one statement is true, hence the complete condition becomes true, right? And then finally the not operator, right? uh, not operator is just straight not 7 greater than 0, which is basically essentially false. So this is 7 greater than 0 is true, but what we are doing, we are applying a not operator on top of it. So because this condition is true, on applying not, it becomes, condition becomes false, right? So that is how you use not operator. So then again, like there are, to control the loops, there are multiple to control the loops, there are three different methods that you can use. You can, to jump out of the loop, right? Let's say if your condition is met, you can also use break to close the loop directly, right? Uh, Directly break the loop and execute the next line, which is out of the context of, like out of the scope of for loop or while loop, right? Then continue is another statement. Continue is another statement, which basically, let's say it basically skips whatever return below continue in the for loop or while loop and starts from the beginning again. Then pass is nothing but a placeholder. It basically does nothing. Okay, so these are more examples in for loop, right? So this is just nothing but printing the values which are there in this particular list. We'll be looking what list are. So this is yeah, but this is basically, for loop basically iterates over the values which are there in, like which are there in the list which comes after in statement, right? So similarly in range 5, there is nothing but it will be counting to 4, like Python range, it starts from 0. So in this case, start point is not given, hence it is assumed 0 would be the default value, and hence it starts from 0, goes till 4, right? So range n basically generates values from 0 to n-1. So that's how the range function is. Yeah, moving ahead. Yeah, data types in Python, everything is an object, right? Be it class, function, which you would have uh, seen in C, C++, Java, right? Everything is an object. So x equals to 7. So x, in the variable x, we have stored the value 7, right? So x is an object which is of type integer, right? So x can be again assigned to a different object, value, which is called hello, which is a string. So x becomes object of type, like strings are notified as a type object only. So yeah, so that's the data type. So we already have we seen integers. So there are long integers as well, in similar to how there are unsigned integers in C, right? Unsigned integers. So there are different methods to show long numbers, right? So similarly, there are different methods to show long integers as well in Python. So floating points, we saw this previously, right? Floating numbers. If you, let's say, if you just want the complete number, right? Any number that you want in a float format, you just typecast it as float x, and that basically typecast that particular number to a float. Let's say you want to convert a floating number to an integer data type, you just do int x, and that's how you get integer. Python also has the facility to write complex numbers as well. So that's inbuilt, right? So in this case, as in the example that as you can see x equals to 3 plus 2j, 2j being the imaginary part, right? And then in y, they are writing minus 1j as another value, right? So x plus y, x into x, x asterisk y. So you can execute these complex calculations as well in Python. They come by default in Python, right? Okay, so data types for data collections, right? So how we are handling. So in this case, we have lists, sets, dictionary. We have also, like Python also have tuples, right? So each of them have different uses, right? But for data science, usually list and dictionaries are the one which are heavily used, right? We will come to so we'll look into what lists are and what dictionaries are, right? So all the lists which are in Python starts with 0, right? That is something that we should be aware of, right? Similar to C++. So starting with lists are ordered sets, or lists are basically ordered collection of data, right? So in a list you can store any numbers of objects. So these objects can be int, float, functions, the functions themselves, right? Functions, complex numbers, strings, and so on. So these lists are basically are a array, which is similar in C++ array. Mm, array of objects, right? In C, you would have to define array to be of int, right? So only int can be stored. But in case of Python, you can store any amount of objects into it, right? So lists are basically mutable, and so that is something one needs to understand. Like one needs to take care of, like have it in the back of mind when they are writing codes, right? So there can be problems when different lists are being passed around in the functions. So one must make sure the list, uh, like one must keep in mind the lists are mutable and can have any type of object, right? So similar to, let's say, so basically let's say in the list how to access the elements, right? So these are indexed from 0. So one in this case has the index value of 0, hello has the index value of 1, and 3 plus 2j has the index value of 2, right? So let's say if I print just do x, the complete list is printed, but I do x in square brackets 2, it would specifically access the second, like index, the value which is stored at the index 2, right? Which is nothing but 3 plus 2j. Let's say I want first two values of the which are there in the list, right? So what I do is I do 0 colon 2, right? So this nothing but 0 is the start, right? Similar to range, and 2 becomes the end point, right? So the 2 is basically exclusive, so this is not counted. So like 0 and index number 0 and index number 1 are only printed, right? So just remember that. So this is how basically Python behaves. So last value is basically like index value is ignored and it just goes to n minus 1 value. Yeah. So going ahead, list you can do, there are multiple functions which can be used on top of it. Let's say you want to append objects in the list, right? So you use append function which is in the list. Let's say you want to insert a particular value at a particular position, right? So you use insert function. You want to remove a particular value, you want to pop up last value, right? So pop index, let's say you want a index for a particular value which is present in the list. So there are different functions which can be applied on top of list, right? So let's say you want to count number of time x has appeared in the list. So you just do count x. You, let's say if the list was of numbers or alphabets, right? So list dot sort would basically sort the numbers, or in case if the list was of completely of alphabets, it would basically sort in the alphabetical order, right? So lexicographical order. So sort, reverse. So these functions are also there built in by default in Python. Let's say you want to modify a particular value at a particular index. So for that case, you just have to do x and the index of the position value which you want to modify, and you just reassign the new number to it, right? So in this particular case, let's look at the example, right? Let's say if my initial list was x equals to 1, 2, 3. So what I'm doing is I'm assigning y to value x. So now y also points to the memory location where the value 1, 2, 3 is stored, like as a list is stored. So now let's say I want to modify the value which is stored at position number 1, right? So what I do is I just do x1, the index number. So in this case, index the value 2, that is being reassigned to value 15. So in the memory where 2 was written, 15 is basically stored. And let's say if I print x again, I would be getting 1, 15, 3. And previously, as y was also pointing to the same location, which x was, y in the y also the value of the value in the position 1 is changed to 15, right? So that's how it goes. 1 second. Yeah. So let's say if I want to append a new number 12 at the end of the list. So I just write x dot append and the value 12. So that basically appends 12 as a value to the list at list which is associated with the variable x, right? But then again, y was already pointing to the same list, and hence the y list is also modified. So this is what I meant. You need to be careful how you are like x being mutable, and if you pass a list around in different functions, the values for the list, the content can change, right? So you need to be very careful on when you are using or passing list in different in functions, right? Because like same similar to the example, same location, same memory location is used, right? Coming to the okay, sorry, next slide. Yeah, so in this case, yeah, one thing to note, append basically any list dot append basically returns none if the addition was success, right? So in this case, as you can see, x dot append is basically returning the value which is returned is stored in z, and z, if you compare with none is basically the null character in Python. So that's true. So hence nothing, basically none is returned whenever you use append. And there is one another method. Basically, let's say if you want to combine two different lists, you can use plus operator. So in this case, we are overloading the plus operator. So in this case, what you are doing is and basically that would return a new array, because the list was like the two different lists were merged, and hence let's say the original, if I do x plus another list 9 plus 10, so that basically becomes a completely different list, right? And a new memory location is allocated to it, because like you are appending two different lists. So a new memory location which has the new updated list is allocated, and hence x becomes 1, 2, 3, 12, 9 and 10, but y still points to the old memory location, and hence y the value of y is not updated, right? So these are the different behaviors on how you when you modify the lists. Yeah, going ahead to dictionaries now. Yeah, so dictionaries are also very heavily used. Dictionaries are nothing but key value pair. Dictionaries, in dictionaries you basically get key value pairs. You can store objects as key value pairs within dictionaries, right? Dictionaries are mutable, right? When you pass around the dictionaries, the functions can basically change the values, right? So what I mean by key value pair is, let's say in curly brackets, you write, you assign a variable d with with this particular syntax, right? Colon means 1, 2 as a string means integer 2, 3 as a string means integer 3, right? So now let's say if I want to access any one of these, so I just need to do d, and I just need to pass the key, and that would basically give me whatever the value which is stored at the key 3, at this particular key. So you basically use dictionaries uh, as a map, which are similar in C++. Yeah. So the access time is basically reduced, highly reduced. In this case, you are directly accessing the value, and hence it's like order 1. It happens. Yeah. Let's say you want to modify new objects in the memory, in a dictionary. So let's say let's say if I have a dictionary D which has first key as integer 1, which has a value 1, which has a value hello, and then the another key is 2 as a string which has a value 42, and then third key is blah as a string, and it has a list of numbers, right? And let's say if I modify the value which is stored along with the key which is 2, right? So if once I write it in this format, so I can directly reassign the value of this particular key, and I just do equal to 99. So 99 overwrote 42, and that's how the updates are done. Let's say you want to add a new key value pair. So what you do is you just do d and write the new key equals to the new entry that you want to enter, right? So that's how simple it is to write new write new key value pairs within a dictionary. Yeah. Let's say you want to delete a particular entry which is which is there in the dictionary, right? So let's say if my original dictionary was d, as shown, so 1 has the value hello, 2 as a key has a value there, 10 has the value which is world, and I just want to delete the key value pair of which is stored with the key 2. So I just do del in brackets, I write d2, and that's how it deletes the key value pair which is stored with the key 2, right? So there are methods to iterate over the dictionary as well. So what you do is you just do uh, remember in for loop, anything after in is basically we need a group of variables on which the for loop would be iterating for. It can be list. So so there is a question, position of the new entered value in the dictionary. So that basically it can be anything. So dictionary by default it stores in a sorted manner, lexicographical order. Okay. So anything that you enter new is stored in the dictionary in a lexicographical order, right? So order is not something that is basically paid attention or used in a dictionary. So dictionary are basically used for the quick access that it provides, right? So with just order 1 in just one step, it can quickly give you the key value pair, and that's how it basically is used. But at times when you want to iterate over the loop, over all the values of dictionary, so what you do is you just do dictionary dot keys. That basically gives you a list of all the keys which are there in the dictionary, and with that you basically can iterate over all the key value pairs. So what you do is you just print k colon and just do address k. So that way each of the associated for each of the values, key value pairs are basically printed. K becomes the key and address k becomes the value, right? And that's how you basically iterate over the key value pairs. Let's say if you wanted to iterate in a iterate in a sorted manner, so what they're doing is sorted key, you just sorted is another function which comes in by default, which sorts the dictionary, sorts the value whichever is written, right? So key address.keys, it internally sorts the keys, which internally, can I remove this? Okay. Um, so I would request participants to please don't annotate anything on the screen. Yeah. Okay. Mm, yeah. So this is how you basically use sorted function, and you can print the key value pairs which are there. Okay. Going ahead. Just a second. I will try removing the annotation. Yeah. Thank you. Yeah. So copying dictionaries and list. So as we have seen, like copying a perfect dictionary, like let's say if I assign, we have seen assigning y equals to x, where x is a list, and that list itself became the both the variables were pointing to the same list, right? And let's say in at times we don't want to modify both the lists, right? We want two different lists for two different functions. So in that case, what you do is, list is a built-in function which can help you copy list particularly to a different variable, right? So let's say L1 equals to 1, that's basic essentially a list, and I want to make a copy of this one in a different memory location, right? So I assign it to L2 with list as a function, right? I do list L1. So this particular list is assigned to a new memory, and L2 gets a copy of L1, right? Now I can do any number of permutation, like any number of computation on L1, and L2 value of L2 won't be changed. Similarly, for dictionaries, you just do dictionary.copy to copy the complete dictionary to a new memory location. Yeah. So that's how copying of dictionary happens. Okay. Moving on. So what we have seen is integers, floats, complex numbers. Okay. So any questions till this point? I see a request from Professor Ashmita talking about asking for Hindi language as well. But feel free to uh, को, कोई भी सवाल रहा तो please go ahead, just directly ask. पूछ लीजिए. I'm just sticking to English just for the larger audience. But in case anything is not clear, in case you have a particular question, please do ask. Like anything on list, dictionaries, else if conditions, the conditional statements, for loops, I'm happy to answer, right? Before I move ahead. Okay. Cool. So going ahead to functions, what functions are? Till this point, we basically we very quickly saw what are the basic data types which are often used, like heavily used for any data science, machine learning functions. So these are also very basics of Python, right? It can be found anywhere. Like you can Google search them. Like let's say if you want to do practice, I would encourage you to do hands-on, right? There are multiple websites where you can train yourself for getting better in Python as well. So I would encourage that. But now let's coming back to functions, what functions are in Python. So remember, I said there is something called range. Like we talked about range, we talked about list, right? List as a function. We talked about int, where we any number, if we give to the function int, it would return it as an integer, right? So what these functions are, so the how can we ourselves write these functions which we can use again and again. So let's say we want to define. So what you use def, which which short form for define. So you just use def and the function name and the arguments, right, to write to start writing the scope of the function. Anything which is within, like within the indentation of def, becomes the scope of the function, and all of it is basically executed as many times as you uh, call the function. So in this case, let's say in my function basics.py, I wrote this def function, like max function, where it basically compares if x is less than y, return x, else return y, right? So let's say in my code, if I do import and import or this particular file, right? So this max function would become available for me, right? So what I do, let's say max of just wait. I think the sign, this operator sign needs to be corrected. This is my bad. This slide needs to be corrected. Yeah. So what this max function, by logical, it needs to return the maximum value, right? So in this case, in this case, max of 3 and 5 is basically 5. So that's what it is returning. Between the two strings, it's nothing but it's calculating what is coming lexicographically later. So it compares the two strings, whichever is lexicographically larger, it's sending it back right there. In case of comparing between integer and a string, in this case, it also does a lexicographically higher value and sends back, right? So that's why hello is returned. So at the end of the day, functions are nothing but objects, can be used, can be assigned. Functions can directly be assigned to variables. It can be passed to different functions as a parameter, right? And functions themselves can be returned from different functions, right? So this all happens because Python treats everything as objects. So that is why, like, it can be passed around as a variable, passed as a parameter, can be returned as a function, can as a value of functions as well. So function name can be anything like similar to variable names as well. Let's say I first define x equals to 10. The value of the x is basically now pointing to a memory where the value 10 is stored. But let's say I define x which says print hello. So x now becomes a function which is stored at a particular memory location. And whenever I call function x, it returns me, like it basically execute whatever is written within the function x. Let's say after that I assign x to different value, so that value becomes reassigned, right? So this is how, like, because everything is treated as an object, the variable names, it can be assigned to anything, right, and can be used. So you would have to make sure you are using different variable, you are not using same variable name throughout your code, right? You would have to use variable names which are logical and make sense for the code itself. Let's say if you are squaring a number, right, you write that number explicitly. Okay, this is a particular number which is going to be squared, so that other person which reads the code follows it correctly, and you yourself does not. Yeah. So there is a question: is there a difference between x and x parenthesis, the brackets, right? So x is, in this case, x was not called, like once the x function was defined, in this case x was not called as a function. We just got the definition, which is whatever is stored in x, right? But whenever you call a function, so call a function with square round brackets, this is basically initiating the function call, right? So that's the difference, right? At if I have just done x, right, if I had just do something like this, it would just return me where this function, what is stored at the function x, right? But after calling function, the whatever there is, the statements which are there within the function are executed, right? Okay, going ahead. So this is an example where functions can be returned as parameters, right, and can be sent as parameters. So let's say in my code, I write a function foo, where it takes first argument f and second argument a, and it basically applies function like if it applies f, whatever that f be, f can be any function, to the argument a. And let's say my function is bar x, which basically multiplies, like basically multiplies by itself, basically doing a square, right? So and I import this function in my code, and I do foo. First argument basically is a function, because we know f needs to be a function. It's going to be applied to a, to whatever the second parameter is of foo. So we pass the bar as a function, as a parameter, and then the value 3, which is to be used as an argument in bar. So foo takes bar, yeah, applies, multiplies 3 by itself, and then returns 9, right? Foo. So this is how functions can be passed in as a parameters as well. Any questions till this point? Yeah, any questions till this point? Like we have seen the basics which are going to be used, which are required, right? Okay, cool. I will be switching the slides. Just give me a second. So we till now we have covered basics which are there in Python, which one needs to know. One needs to have a thorough hand before moving ahead, like getting their hands dirty with the machine learning, programming, and so on. So my screen is visible, right? Yeah. Okay. So let's start with data visualization, data analysis with Python, how that's done. So with all the knowledge that we have, right? So there will be a steep curve. Like we started with scratch, right? So now coming on to how different modules are used, right? So bear with me, like here this once is to get an idea, and then maybe go back to your systems and check out how that's done actually. Get your hand dirty to understand it thoroughly, right? So data visualization and analysis with Python. So popular tools first. So we have question: can x take two values, one as a variable as well other as a function? So it depends. So it totally depends on the execution that you are doing, right? Let's say yes, this x can can have two different values, as I mentioned. In Python, object, like Python treats everything as an object, right? So x as a variable can point at starting to a particular number, right? But then again, let's say in the flow of the execution, let's say if you updated the value which is stored at x, it would may as well point to a function as well, right? So one needs to be very careful on how they are using the variables and what names that they are storing in the variables, right? So that one does not confuse it, and reuse the variables which are there. So one has to be name the variables very carefully when handling such cases. But let's say if your case requires a particular variable name to store two different values, you may as well do it, right? So that's possible. Okay, so there is a very popular package for numerical computation in Python. Like it is the by far most used in Python, right? All machine learning algorithms which are there, which are written in Python, are basically backed by NumPy, right? So like it is heavily used for machine learning workloads, and any mathematical computation, NumPy is the library that you'd be going to, right? So it's standard. It does all the vector operations. So we remember, right? We teach vector operations, vector addition, vector multiplication, and so on, like transpose, depending on how the use cases are. Like there are like vector multiplication, like vector operations are something are very big in mathematics and are used often for a lot of different use cases, right? So to handle such operation, NumPy is the library which was written. It is written in C. The backend it has is in written in C, and it is very fast, right? Since it is very fast, it has been re-implemented. Like since it has a backend of C, it is and fast. It is used as a de facto standard for any mathematical computation, right, involving large amount of numbers in Python, right? So what you will find in NumPy array? So in NumPy array, essentially all the values are stored as multi-dimensional arrays. So do note this NumPy array is particularly for integers, floats, and complex numbers, and so on, right? So this tool has to uh, do with numbers only, numbers, decimals, floats, and so on, right? So it stores everything as multi-dimensional arrays, which is oriented for like fast arithmetic and arithmetic operations. So right, like we in Python, we already have for loops and lists, right? But because they are slow, they are not optimized for arithmetic operations, right? NumPy is widely used, right? For any linear algebra, for Fourier transformation, all of it, right? Random number generation, all of it you can find in NumPy. So, so what's NumPy array? So NumPy array is the NumPy ND array is an object, is basically a fast and flexible container for large data sets, that large numbers, right? Even though Python has lists, they are very slow. I would request participants to please don't annotate on the screen itself, right? Mm, Uh, I believe like the slides would be shared with you, and you can use that as a reference for yourself, right? Yeah. So NumPy arrays are like Python arrays are very comparatively slower and cannot be used for arithmetic operation, and hence NumPy arrays are which are de facto standard for any for any mathematical computation. So we have a question like, yes, we will be seeing now examples for NumPy array and how that is used in code, right? Mm, okay, so ND arrays, like you can in a list you can store list of lists as well, right? So you can have any number of list within a list, but the benefit of using ND arrays is basically that benefit is very significant. The advantage is they are very fast for arithmetical operations, and Python lists are not at all optimized for optimized in sense they don't have functions like matrix multiplication. They don't have functions. They don't have anything to do with operations, arithmetic operations, and so on. Yeah. Hence, ND arrays are preferred. So how do you create NumPy arrays, right? So very simple. What you do is, let's say you have a list of numbers. Just a second. Let me bring the pointer eraser first. Yeah. Okay, let me get the pointer now. There's a pointer. Yeah. So in this case, you basically just directly import NumPy arrays and NP. Then you define a list, right? And you just do np dot array and give the argument, like pass list one as a parameter, and that basically essentially converts this list and store it basically back to the different variable, right? ARR. So that ARR is nothing but the NumPy array, right? So let's say when you want to type, like know what the type is for ARR, you just do print type ARR, and that print that gives you now that ARR is of the type NumPy ND array. And let's say if I print ARR, it would basically essentially just print the NumPy array. So that's a common way to convert. That's a very simple common way to convert any list to a NumPy array, right? It's basically NumPy dot array function that can be used. So there are key differences between list and ND arrays. ND arrays are basically designed to handle vectorized operations, while Python lists are not. That means you can apply functions on the complete ND array, right? You can do array addition, like vector addition, vector subtraction, vector multiplication, and so on with ND arrays, right? With list, all of that is not possible. So this is here an example, right? So let's say if I have a list L1, right? If I have a list L1 and list 1, which has value 0, 1, 2, 3, 4, right? And I want to append another number to L1, right? To list 1. So this basically is a wrong format, right? As we have seen in our previous as we have seen in our previous example, to combine two different lists, we would have to both the combination needs to be like, both the things need to be list. So list 1 is a list, right? But plus 2, like 2 is just an integer, and hence it cannot be concatenated. Like it gives you a type error. You cannot concatenate the list, like integer to a list, right? But let's say but that is not what was desired, right? Let's say you wanted to do vector addition, right? That's what you meant by list 1 plus 2. So this is not how you do it. So what you do is, for doing vector addition, what you do is you create the list 1 as a NumPy array, right? And you do ARR plus 2. So in this case, what's happening is, when you define the ARR, you print it. So you get 0, 1, 2, 3, 4. And when you do ARR plus 2, it's basically doing a vector addition. So it's adding 2 to all the values which are present there in the NumPy array, right? So that's how you do vector addition. So that's how this is optimized for vector addition, like vector operations. And lists are not, Python lists are not. So yeah, it should be noted, like once any NumPy array is created, its size cannot be increased, right? You can change its like all the data which is there, right? Let's say it's in 3 dimension. You can change, massage it to coming down to a 2 dimension, and but the size, the amount of data which is stored within it, right? that cannot be changed, right? So what I mean by massaging is basically doing some transform on top of it. At any time you want to add new data, let's say you want to add a new array within a numpy array, or any you want to change anything, so that basically is reassigned to a new memory location. Yeah, so that is something which is noted for numpy arrays. Okay, so how to create a two-dimensional arrays? So what you do is you take a list of lists, right? So list2 is a list of list, Python list of list, right? So where 0 1 2 3 4 5 is another list, 6 5 6 7 8 is the third list. What you do is you just simply do numpy.array of list2, and you get the two-dimensional matrix. Yeah, so you also have a argument where you can define the data type. In this case, all the numbers in list2 were just integers, but if I do a typecast it to float, when I'm converting, everything would be converted to a float, right? So that's how you do, you use d-type argument. Let's say you want to typecast a list into a different format, right? So as type is the function that you use. So let's say in this example, from what I have, 0 1 2 is first list, so on till 8. So I converted to a float array, numpy array, which is of type float, right? So on print statement you can see all the values which are there are in float, which has 0 0.0 1.0 2.0 3.0 and so on. So this, let's say if I want to typecast this as a string, so what I would do is I would typecast it first as an integer and then use as type to typecast it back to strings. So that's how basically I got all the items as a string. And remember, unlike list, all the items needs will be on the of the same type only, right? Numpy arrays cannot store multiple types. So in Python, just a second. So in Python, object is the type which is generic, right? Object, the strings are of type string str, and they are of type object. Like the d type for them is object. So let's say if I have I want to have a numpy array which would have 1 and a string a, right? To, like, if I didn't pass d type equals to object, this would have failed. But since I'm passing d type as an object, everything internal to it would be treated as an object. So all the data types, like 1 would not be no longer be treated as 1, like as an integer. Vector addition, subtraction, the vector benefits that numpy gives will no longer be applicable. So it would just become a numpy array of type object. Like you would not be able to do any mathematical operations on top of this. Bharti, do you have a question?
Sir, previous slide, sir, once previous slide.
Okay, what do you have on previous slide? Just a second.
Conversion.
Okay, conversion. Yeah, anything here?
Okay, sir. Okay. I want to note, sir.
Okay. Yeah. Okay. So let's say from a numpy array, you want back it as a list. So numpy array has a very convenient function which is called toList. So any numpy array that you have, you just do toList as a function on top of it, and you would get back the list as an output. Just a second, just a moment. Yeah, sorry. Um, so any numpy array can be converted back. Can be converted back to list with the function to list, which is provided there in the numpy. So let's say you want to inspect the variables which are there. Yeah, so let's say you want to inspect the variables which are there in the numpy array. So what are the different values which are what are different methods that you can use, right? So with arrays you can do shape, like basically to know what is the shape, what dimension it is of, right? You can use d type, array.d type, array arr3 d type, right? You can use size, which tells us total number of elements, right? You can use n dimension, basically telling us about what are the number of dimensions which are there in the list of the array, right? So these are the different methods that you can use to to these are the different methods that you can use uh, to basically inspect the arrays. So let's say at times you would want to do slicing and dicing of the numpy arrays. Let's say you just want to access particular values which are there in the array. So what I would do is, like, I would convert first list 2 into a numpy array, right? So in this in this particular line, I'm printing the whole array which I have, right? So I'm seeing the complete array which I have. But let's say in my array, in the first dimension, I just want first two elements, right? uh, like I just want these first two rows, and then in the second dimension I just want the first two columns, right? So because, like, there is before colon there is no value, it is by default assumed to be 0. Same in this part as well. By default it is the columns is assumed to be 0, right? And when I do colon 2, 0 and 1 are the only elements which are selected. So last element is basically from the count, right, till 2. So first two rows, and in this case as well first two columns. So that's how I get a part of the complete array, which are first two rows 0 1 3 4, and first two columns 0 1 3 4. And that's how I'm able to do slicing and dicing. Could we have an example live demonstration? Yeah, we will check we will check numpy arrays out in the demo, right? In the demo slide that we have. Sorry, we didn't connect. There are a few questions which are going. Okay, yeah. Going ahead. So Boolean operations are also like you can check which values are, like, Boolean operations are also possible. Like you can use Boolean operation to filter out the values which are required, right? So Boolean operation in sense, let's say I have a list, and I convert it into a array, and I want to know what are the different values which are greater than 2. So I just do the array ARR3 greater than 2, and I get the output as whichever values, which the false would represent whichever the position where less which are greater than which are less than 2, and true would be representing which are the values which are greater than 2. So this is how basically comparison can happen, and you can use these comparison to basically create filters to obtain the values which are satisfying certain conditions. Now,
Sir, I was
Panda.
having one doubt.
Yeah.
Sir, can you take to the previous slide?
Sure. Yeah.
Sir, ARR3, one array we have created, right? And after that,
Yeah.
BOO we have created. So after writing this condition,
Hmm.
we have printed BOO, right? So
Yeah.
ARR3, that array whatever we have taken, that one is immutable, sir.
Yeah. So see, it is immutable. We cannot change the content of array 3. What we are doing is we are evaluating this particular condition. So given
Okay.
we know numpy arrays, we can do vector operations. So we are comparing whether each value present in array 3 ARR3 is greater than 2 or not. So
correct, sir.
that's how these are false represent the position which is less than 2. True represents the position which are greater than 2.
Yes, yes.
Right?
Means new object is created, and that
yeah. So
the
boo
previous
is the
one
new object.
immutable. Correct.
Yeah. Boo. So boo then again is a new object. It's a numpy array of with d type as boolean. Right?
Okay, sir. Got
Array
it, sir.
ARR3 is not muted. Yeah.
Yes, sir. Thank you, sir.
Yeah. So pandas is the next popular frame Python module which is used for data analysis. It is also a high level abstraction over like it is used with the help of, it is built on top of NumPy, and it has a backend which is written in C. It is very high performant, easy to use. It gives so the two main data structure which are present there are data frames and series. So let's say if the data is of one dimension only, then it's series, it maps to series. Let's say if the data is of to a multiple dimension, uh, uh, not multiple dimension, it can handle up to 2 dimensions only. So that basically data frame then 2-dimensional data maps to data frame, where each row is assigned to an index, each column is assigned to a particular column value, right? So pandas becomes like similar to NumPy. NumPy excels at doing vector operations like algebraic calculation and so on, right? Which are very much essential for machine learning calculations, right? Similarly, pandas is essential for transforming your data, right? So any transform on column, any yeah, so any transformation that you do on columns or the complete data set, yeah, you would be using pandas. With pandas, NumPy is also available, right? So depending on how you use it, you can use column transformation, you can do row transformation with pandas and NumPy together. Yeah. So indices, so every row is basically assigned to an index in pandas. So let's say as I said before, in pandas there are two data types. One is series, another is data frame. So given this is in our example, this is a single dimension list, it is basically mapped to series, and it's like each number is each value is associated to an index. So 0, 1, 2, 3, 5, like because we have not given specified the index values for this particular list, it is also auto assigned by 0, 1, 2, 3, 4, 5. Yeah. So this is how like it goes from 0 to n-1 by default. Let's say let's say I define a list, like I define a panda series, right? Let's say we defined a panda series with using the list 5, 6, 7, 8, 9, 10, right? And I just want to print the values which are there in the series. So I just do print the series dot value, and I, let's say if I want the value which is at 4, position number 4, right? So 0, 1, 2, 3, 4. Then so hence 9 is printed. So that's how you can access the values which are there in series. So do note, this is specifically for series, right? The value access was for, and because this index is not defined by us, so hence it's like 0 to n minus 1 values are assigned as an index. But let's say if we assign an index manually, so this is the second case. Pandas, you give a list, index A, B, C, D till F. So 5 is mapped to A, 6 is mapped to B, and so on. F is mapped to 10. In this case, if I print the values, I get the complete panda series. But if I do series.f, new series.f, like this F, I will be getting the value 10 because 10 is mapped to F. So that is how that is why index, that is how the index are used, and index are there in pandas, right? So then again, like it is very easy to retrieve and mutate multiple values with pandas. You can directly use the index values to mutate them, right? So in this given example, like that we used from our last example, we are just doing reassigning the values of the index A, B, and F back to 0, right? So this new series, in this series, A, A is mapped to 5 at first, B is mapped to 6, F is mapped to 10. That you can see when you are printing the series, right? A is mapped to 5, B is mapped to 6, F is mapped to 10. So as soon as I do reassign these indices, the values assigned to this indices to 0, the new series looks like this: the A is 0, B is 0, F is also 0. Rest of the values are as it is, right? So as you can see, this pandas data frame are mutable, like they can be changed, the values can be itself be changed. Hence I said these data frames can be used, can be easily used for transformations, right? Any changes, vectorized changes that you would want to do. So pandas is the way to go. So you can also create new series, right? Like with operations, vector operations, right? Like let's say if the series you want to check, okay, create a new series for all the values which are greater than 0. In new series, I define like that I define. I'm doing new in the new series itself. I'm applying an operation. New series greater than 0. I'm printing out the new series, right? So that's how so I'm getting this new series itself. So this operation is particularly applied. New series greater than 0 is applied on the index values, right? So this is something that needs to be noted. It's being applied on the index value. So, and because this all the values like alphabet, and hence it's treated as greater than 0 lexicographically, and hence it's coming it as it is. But let's say and like all the values are there, but let's say in my new series greater than 2, and I apply star 2, so it's not doing anything, right? Because none of them, like this doesn't satisfy, like ABCD is not satisfying the constraint for 0 greater than 0, and hence it's not being able to do any changes on this top of this. So index needs to be on numbers when you're wanting to do any kind of mathematical transformations. Let's coming back to pandas data frame. So in simplistic terms, each like you can see like you can see, think of it as a table, right, in the memory, which is called data frame, and each column is nothing but a series, right? Row consists of element which are there in the series. So like case id is nothing but the index, right? So one becomes the index for this complete, like in the column variable 1 1 2 3, the index for variable in the column 1 2 3 is case id 1. Similar for variable 2 abc, the index is 1. So that's how is basically measured. Going ahead, right? Panda's data frame can be created from dictionary as well. Let's say, as I said, columns are the series and rows are nothing but basically the index associated with the index in each of the series, right? So let's say if I give country, like if I give a dictionary where country, population and square, basically the area, right? And each of them have a list: Kazakhstan, Russia, Belarus, Ukraine, population in millions, right? And the square kilometer area, right? So if, once I give a dictionary to a data frame, it would create it as a two-dimensional data frame, right? Where index 1 for Kazakhstan. Let me just mute everybody. Yeah. So the index 0 is mapped to Kazakhstan, population which is 17.04, and the square kilometer square area, yeah, 272490902, right? So that's how dictionaries can be converted to pandas data frame as well. Moving ahead, yeah, so you can create similarly, like you can create data frames from list as well, from what we have been seeing till now, right? With the list as an input in data frames, and you can specify what are the columns associated with, and this is how you basically do it. Let's say if I type for a particular country, like for a particular in this particular example, right? pd.data frame country, this particular dictionary, right? If I do a type of this, and the country, it basically, like in a data frame, it's nothing but a series, right? So this is what it is validating our claim, that is, right? Each column is a series. So in this sense, each value which is like each value which is there in pandas will have two indices. One is basically the column index and another is the row index, right? Row index would be nothing but the range index, like which is starting from 0 to n-1 if it is not defined, right? Else any index that is given when you are defining the data frame. So there are number of different methods to pass row indices, like basically the indices, right? It can be passed as an index argument, or it can be assigned later on, like once the data frame is defined, as df.index equals to a list which is there, right? And the name can also be, the name of the index itself can also be changed, right? In this case, in this second example that you're seeing, right, we are renaming the index from 0 1 to 3 and no column name to country code, and the country codes KJ, RU, BY, UA, right? So this is how it is done. So let's say you want to access the complete row, right? You want to access a particular index, like complete row values for a particular index. So what you can do is you can use df.lock loc and give out the index value, which is in this case was kz for Kazakhstan, right? What we have defined in our last slide. df.log Kazakhstan, it would basically print out all the data which is there in for that particular row. So this is how you pass the row index. Let's say you want to use numbers, right? Because numbers are often used, right, in our calculation for iterating and so on, and you want the data. So you would be using iloc. So in that case, you would be using iloc to get the transformation, like to extract all the row data which is associated for the 0th row. In this case, it is Kazakhstan, population of the country, and the square kilometer area in millions. Yeah, let's say let's say for 2 different rows, you just want values in a particular series, right? So this is how you dissect it. So what you would be doing is you'd be giving it out in log. You'd be giving it out the row indices which you want, and then comma, and then you just give out the series name for which you want the data for. So in this case, they are using Kazakhstan and Russia and the individual population. So this is basically the command to extract for particular rows the values which are there in particular columns, right? Let's say you want to do slicing, slicing and dicing. You just want a particular, you just want for rows which are between Kazakhstan and Belarus, right? So in this case, let's come to the complete data frame, right? In our base data frame, we have Kazakhstan, Russia, Belarus, and Ukraine in an order, right? And we want all the rows which are between Kazakhstan and Belarus. So and all the data which is associated to these rows. So what you'd be doing is you'd be giving the keys. Okay, I want to go from Kazakhstan to Belarus, and then you just write a colon, because nothing is given between, like, before and after the colon. In this case, all the rows which are associated are printed, right? So this is how it is done for like slicing and dicing, like selecting any rows particularly, and so on. Yeah. Filtering similar to what? Okay, so there's a question around, please repeat on lock and iloc. See, lock, in case of lock, you would have to give the index as it is, like exact index name which is stored, right? In this case, the index where KZ, RU, BY, UA, right? Hence, KZ, those are to be used. But let's say often when you wouldn't be knowing the exact index name, but you would be knowing what is the number, right? Let's say you are doing something in for loop, or you have just the coordinates of it, like second row I want to get, you just want to get a second row. In that case, you use iloc, because like even if we have defined index as like something custom, but by default it's internally stored at 0 1 2 3 4, right? So that is the default values which are accessing, that we would be accessing with iloc, right? Okay, so you can do filtering operations with data frames as well. So how that is done is, remember in NumPy we created a Boolean array based out of, after comparing if the number is greater than 10 or not. So what they are doing is, in this case, what's happening is, they are in the data frame, they are selecting in the series population if the value in the series is greater than 10 or not. For all the values which are greater than 10, right? So this would essentially create a Boolean series which is applied on top of data frame df, and in there you are just selecting country and square. So this is how you basically, with the first conditional step, you have filtered the countries which have population, filtered out the population which are filtered out which the population which are less than 10, like which are greater than 10, and then just selected the country and square. Okay, so similarly for deleting the columns, let's say you want to delete a particular column. So what you would be doing is you would be just doing a drop operation and specify the axis. So you just write the column name, and because this, we know this is a column, so you just type the axis as column, and that's how you basically drop the column. So reading and writing, that's pretty straightforward. That can be done with read CSV.
Sir, please repeat again the previous slide, sir.
Deleting column. Deleting column or filtering are you referring to?
Sir, deleting column and deleting column, sir.
Okay. So in this case, what they are doing is, let's say I want to delete a particular column, which is population, right? So I just write the name of the column with drop function in the drop function, and just specify the axis as columns, right? So this is basically how you delete the column, right? Any questions? Hope that answers. So let's say you want to remove a particular row. So in that case, instead of remember, like, columns are always 1, right? And rows are always 0, like in axis, in this particular axis. So what you would be doing is you'd be just assigning 0 here, and you'd be just writing the index number that you want to delete. So you just write the index number in this list, and you just give axis equals to 0 to delete a particular row. Yeah. Reading and writing is basically straight ahead with read CSV function, which is present there. So together with like, yes, I didn't have much time to cover everything which is there in pandas, also which is there in NumPy. And given that we are short on time, I think I will just stop here. I don't think I will be. Maybe we'll be covering EDA part in the next session. But any questions for now? Slides,
No, sir.
Slides and the recording would be provided, would be shared by PHN, right? So you don't need to worry about it. But yeah, Matplotlib will also be covered. Is part of EDA itself. So that would be covered in that session. Yeah. Any question regarding NumPy, Pandas, Python, anything? If not, then maybe we can conclude this. Yeah.
Sir,
Sorry.
can you explain the delete
No.
drop function?
Drop is nothing but,
Because you are used to DF.
yeah, DF
Print
is the
DF
data
means
frame. Data frame. So remember, like,
DF
our
dot drop.
origin, DF is the data frame where we have all the data right now for country, population, and square kilometer, right?
Okay, sir.
So to drop a particular column, we on that particular data frame, we just do df dot drop and then execute it.
Okay.
Okay. Okay then.
Okay,
Where
sir.
we write this code. Okay, one final thing. Let's say you want to do practical. Right?
Excuse me, sir.
Yeah. Go on. Hello. Okay, since no one's speaking, so the code you'd be writing.
Excuse me, sir. Excuse me,
Yeah,
sir.
go on.
Yeah, I have one question on the modify content appending that slide.
Append what part, like list?
Append. Yeah, list. That one
Okay.
function. There's one, you are given 1, 15, and 12. There's one question in that regarding that.
1, 15, 12. Okay, go ahead. Like that would be in another slide, but yes. Can you
You have taken x bracket 1, you have taken as 15. Actually, 1, 2, 3. So x1 you mentioned, and then it is taken as equal to 15. So it has taken, actually you should replace the first integer, no, 1, 15. It has replaced the second integer.
So there was one question on how to execute the code. So it can be done. Just a second. I'll just show that and I'll answer your as well. Sorry. Okay, where is this typing? So code can be executed in your now that you have installed Anaconda, Python would be installed, right? You can execute it in your Jupyter Lab as well.
Yeah.
But let's say, like for the sake of the question that we have, 1, 2, 3, right? So X is my list. Let's say if I want to modify the content which is stored at index number 1. So, so index number 1 is 2, right? Now let's say if I modify the content equals to, let's say 15.
Yeah.
So if I print it, so the expected response is the very value 2 is overwritten with value 15. So that's how we get, right?
Okay.
So that's how it's done. So it's in the same memory because the lists are mutable, right?
Mutable. Okay, sir. Okay.
Yeah.
Thank you, sir. Thank you.
Okay then. Since now there are no questions, what we'll do is we'll just end our session for now, right? Maybe in the next slide, in the next session, we'll be doing exploratory data analysis, where Matplotlib will also be covered, right?
Okay, sir.
Then. Yeah. Thank you. Over to you, Anup. Lalit. Yeah.
Yes. Thank you, Sushant. Thank you for your wonderful session. Thanks to everyone for your participation, active participation. We will looking forward you for the next session.
For more videos, download our app from Play Store.